All right, here are solutions for quiz 5 for Math 112. This first problem that has, 6 different parts is essentially just asking you questions about your unit circle. If you have it all memorized, I think you can figure out all these values. The first one is asking you for the sine of pi over 6. So what you need to know is that on your unit circle, pi over 6 is talking about the point that's somewhere over here. And the coordinates of this point are root 3 over 2 and 1/2 respectively. And since we're talking about the sine of pi over 6, we want the y coordinate of this point, which is 1/2. Thus, the sine of pi over 6 is just 1/2. For the next one, the cosine of negative 3 pi over 4, there's a couple different ways you can get there. One way is you could measure in the negative direction 3 pi over 4. Well, since pi was halfway around the circle, 3/4 of pi would kind of be 3/4 of halfway around the circle. And I'm going to measure this in the clockwise direction to get there. I'm referring to this point down here. Another way you could get there is you could say negative 3 pi over 4 is coterminal with 5 pi over 4. If you add 2 pi to negative 3 pi over 4, you get 5 pi over 4. And so we could measure 5 pi over 4 in the counterclockwise direction to end up at the same point. Either way, we're talking about this guy. Both the x and the y coordinate of this point are the negative of the square root of 2 over 2. But it's this negative root 2 over 2 that's your answer, because again, we want the x coordinate. Tangent of 7 pi over 6. 7 pi over 6 is actually pretty close to this point here. The way you can think about it is it's a tiny bit, pi over 6, more than pi. So measuring in the counterclockwise direction, pi gets me over here, and another pi over 6 takes me to this point that's roughly speaking right here. This point is very similar to this point that we see in red here, except since it's in the third quadrant, its x and y coordinates are negative. So it's negative root 3 over 2 and negative 1/2. And since we want the tangent, unless you already have the tangent memorized, what you can do is take the y coordinate and divide it by the x coordinate. So my y coordinate is negative 1/2, and my x coordinate is negative root 3 over 2. And when I'm dividing fractions, I multiply by the reciprocal of the denominator. So it's negative 1/2 times, and then take this negative root 3 over 2 and flip it upside down. So I get 2 over negative root 3. The negatives cancel to make it positive, the 2's cancel, and I'm left with 1 divided by the square root of 3. However, it says to not leave radicals in the denominator of my answers, so I'm going to multiply the top and the bottom by the square root of 3 and get root 3 over 3 as my final answer. Part D, the cosecant of 13 pi over 6. So again, what would probably help is to find a point that's coterminal to 13 pi over 6, because 13 pi over 6 is not in the 0 to 2 pi range that you might have memorized. So if you subtract 2 pi from this, 2 pi is 12 pi over 6. So what I'd be left with is just 1 pi over 6. So the cosecant of 13 pi over 6 is the same as the cosecant of pi over 6. As we saw before, pi over 6 is referring to this point. For cosecant, you can get here a couple different ways. One option is to say it's the reciprocal of the y coordinate. So the y coordinate is 1/2. So the reciprocal of 1/2 is just equal to 2. Another way you could get there is you could say that the cosecant is defined to be 1 over the y coordinate, which is mathematically is the exact same as the reciprocal. And if I take 1 and then divide it by 1/2, make that 1 over 1 divided by 1/2, and then do the same trick that we did here to divide fractions, and you'll end up with this same value of 2. What about the secant of pi over 6? Well, nice that it's pi over 6 again, because that's again referring to this point, which I know the x and y coordinates of. So all I have to know is how to come up with the secant from the x and y coordinates. Well, the secant is the reciprocal of the x coordinate. So I can take this root 3 over 2 and flip it upside down. Or maybe another way you learned it is it's 1 divided by the x coordinate. So it's 1 divided by that root 3 over 2. And as I kind of alluded to in D, you could think about this as 1 over 1 divided by root 3 over 2, so that you can do our multiply by the reciprocal trick and get 2 divided by the square root of 3. And this is a pretty good answer if you leave it here, but again, you might remember in the instructions it said not to leave radicals in the denominator. So I'm again going to multiply the top and the bottom by the square root of 3, and that'll give me a 2 root 3 up on the top, and the square root of 3 times the square root of 3 is just 3, so I get 2 root 3 over 3 as my answer. Finally, the cotangent of 7 pi over 4. First, let's locate the point. 7 pi over 4, well, 8 pi over 4 would be all the way around the circle, so I'm almost there. I just have to stop pi over 4 short. I'm talking about this point down here. That's pretty similar to this point that you see over here, except that its x coordinate is positive, so I get the square root of 2 over 2. Its y coordinate is still the negative of the square root of 2 over 2. Now that I know the x and the y coordinates, I can come up with the cotangent. Cotangent is the reciprocal of tangent, so instead of y over x, it's x over y. So I take this value and divide it by this value. Well, these values are really similar. When I divide them, they're just going to cancel out. I would be left with 1, except this is positive and this is negative. And when I divide a positive by a negative, I get a negative number. What I'm trying to say is the tangent of 7 pi over 4 would just be equal to negative 1, and that's because the square root of 2 over 2 divided by the negative of the square root of 2 over 2 is just equal to negative 1. On the second page, we deal with values that are not those 16 memorized points on your unit circle. For question 2 here, we're told that our angle t is down here in the fourth quadrant because t is between 3 pi over 2 and 2 pi, which correspond with this point and this point. So we immediately know that the x-coordinate should be positive and the y-coordinate should be negative. It tells us that the cosine of t is equal to 3/5, so that tells us that the x is equal to 3/5, and what we're supposed to figure out is the sine of t. Well, the sine of t is just the y-coordinate, and the equation of my unit circle tells me that x squared plus y squared is always equal to 1. So if x is just equal to 3/5, I get 3/5 squared plus y squared equals 1. And this is an equation that I can solve for y, and if I can do so, I'll have my value for sine. So to solve it, maybe first I'll square this and get 9 over 25 plus y squared equals 1. And then I'll subtract 9/25 from both sides of the equation. So thinking about this as 25/25 minus 9/25, I'm left with 16/25. And now I take the square root of both sides of the equation. Normally I'd put in this plus or minus and say y is plus or minus the square root of 16 over 25. However, since I'm in the fourth quadrant, I know that my y value is negative, so the answer that I come up with is the negative of the square root of 16 over 25, and the square root of 16 over 25 is just 4/5, so my answer is negative 4/5, which I can just write up here. What about the tangent of this value t? Well, I already knew the x value, and now I know the y value. So to figure out the tangent, all I got to do is take the y value and divide it by the x value. All I got to do is figure out what is negative 4/5 divided by 3/5. Well, several ways you can simplify this, but maybe for consistency's sake, what I'll do is the little trick where we multiply by the reciprocal of the denominator. So we take this fraction and flip it upside down, and now you can either just multiply straight across or cancel out these 5s. Either way, you'll get negative 4/3 as your answer. Question 3 is really similar to question 2, except now we are in the second quadrant because our angle is between pi over 2 and pi. So it's in between this point and this point. We're talking about over here in our picture. And instead of being told the cosine, the x-coordinate, what we're told is the tangent. The y-coordinate to the x-coordinate is equal to negative 1/2. What we want to figure out is the cosine of this angle. It's tempting to be like, oh, it must just be equal to 2. It's not equal to 2. This is not telling you that y is negative 1 and x is 2. It's saying that the ratio of these two numbers is negative 1/2. To figure out what x and y are equal to, we have to use the equation of our unit circle, that x squared plus y squared equals 1, in conjunction with this equation to solve for one of the variables. The method that we'll use is substitution, so we'll solve this equation for one of the variables and then plug it into this equation. And really, you can solve this equation for either of the two variables. It doesn't really matter, but if you want to save yourself a tiny bit of time, you could notice that your final answer should be the x-coordinate. So if I could get rid of all the y-coordinates, I'd be able to solve for the x-coordinate. To get rid of all the y-coordinates, I want to solve this equation for y. So I can multiply the x up and get that y is equal to negative 1/2 x, or negative x over 2. And now I'm going to take this value of y and plug it into this equation. So I got x squared plus, and then instead of writing y squared, I will write negative 1/2 x squared. And that's equal to 1. Now I have an equation that only involves the letter x, so I can solve for x. I got x squared plus, if I square negative 1/2, I get positive 1/4. And if I square x, I get x squared. And that sum is equal to 1. Thinking about this x squared as 4/4 plus 1 more fourth, I get 5/4 x squared that's equal to 1. And so if I multiply both sides by 4 and divide by 5, I get x squared is equal to 4/5. So I can solve for x by taking the square root of both sides of the equation. I get x is plus or minus the square root of 4/5. Before I go any further, I should figure out, wait, is it the positive or the negative solution that I want? Recall that we're in quadrant 2, and when we're up here in quadrant 2, our x-coordinate is negative because we're to the left of the y-axis. So again, it's the negative solution that I want. X is the negative of the square root of 4/5, which isn't a terrible answer. However, it says don't leave any radicals in the denominator. So what we want to do is say it's the negative of the square root of 4 divided by the square root of 5. And then we can say the square root of 4 is just 2. So I have negative 2 over the square root of 5, which I can rationalize by multiplying the top and the bottom by the square root of 5. So I get negative 2 root 5 divided by 5 as my value for x, which is the cosine of this angle S. That's about as hard as you can make these questions. The good news is once you solve for one of the letters, x in this case, solving for the other letter is pretty easy. I want the cosecant. Well, the cosecant is just 1 divided by the y-coordinate. So if I could just figure out the y-coordinate, I'd be good. The y-coordinate is equal to -1/2 times the x-coordinate. But I just solved for the x-coordinate up here. It's -2 root 5 over 5. So the y-coordinate is -1/2 times -2 root 5 over 5. Well, let's see, a negative times a negative is a positive. This 2 and this 2 will cancel out. So what I'm left with is that y is the square root of 5 over 5. But I don't want y. The cosecant of s is 1 divided by the y-coordinate. So the cosecant of s is 1 divided by the square root of 5 over 5. If I think about this 1 in the numerator as 1 over 1 to make it a fraction, I can do my little trick where I change division of fractions into multiplication of fractions by multiplying by the reciprocal of the denominator. And so instead of root 5 over 5, I get 5 over the square root of 5, which is just 5 over the square root of 5, which is almost perfect, except I want to rationalize the denominator. On the top, I get 5 times the square root of 5. On the bottom, I get just 5. These 5s cancel out, and my final answer is just the square root of 5. It's worth pointing out that there's lots of different ways you can get here, probably even quicker ways you can get here, but I wanted to show all the steps for the purpose of solutions making sense to a student who might struggle with this kind of stuff. Those are your answers to part 3 here, and that ends our quiz.